We're up to number 3 now, the countdown of the top weather events of the year across western and central Wyoming. And number 3 is the pretty recent one, the snowstorm we had during the middle part of the month in December. Now let's start by taking a look at our surface chart here. You see we have an area of low pressure developing here. That's usually a pretty good location for Wyoming to get snow. And also notice we had a frontal boundary here, basically across the Continental Divide, helping to provide a focus for some of that moisture coming in. Now we had 2 parts of the storm. One of those mainly caused what meteorologists call dynamics. Another one caused more by wraparound moisture and orographics. So I'll explain both those in a minute. Start with the dynamic part of that. You can see this is a 500 millibar chart. We talked about those in the last video. Now notice these height lines. Again, we talked about those last time too. Notice how when they come into Wyoming, you see them splitting apart like this. This is what meteorologists call upper level divergence. Now the weather is just basically an attempt for the atmosphere to try to balance itself. So when the air diverges here, it rises, it has to be replaced by air coming in from the surface. So it rises, it cools off. If there's moisture, you get clouds, and then you get precipitation, in this case snow. So a good setup for that. Now we take look a little bit higher in the atmosphere. This is the jet stream level. You can see the jet here, pretty good jet here, about 100, 110 knots. Actually 125, 100 knots when you look down here across the jet core. Coming from the Alberta all the way down here, all the way down to Mexico, and then coming sharply all the way up here. So a very deep trough in place across the western U.S. And notice how we're in the what's called the left front quadrant of the jet. Now, if you want upward motion in good parts of the snow, you either want to be here or you want to be down here across the right rear quadrant of the jet. And there's a lot of complicated math that goes into that. You can get that out of here. Give me nightmares. Take me back to 1998 trying to pass my dynamics final. In any case, now we'll move on to the other part. This is more of the orographic and wraparound moisture. Here's the upper level low. You can see it was over here before. It shifted over to Colorado. That's a pretty good position for it. Look at the winds. Notice how they kind of wrap around that. And our moisture source is going to be the Gulf of Mexico. Now the question we had here was how much of this moisture is going to be able to make it all the way up and around here. And here's a radar loop during that morning. You can see this is a tornado watch here across Texas and parts of Arkansas, Oklahoma. There were several tornadoes down here. There was actually tornadoes pretty much all the way across Alabama, Mississippi, and some people died here, unfortunately. Now what we were wondering is how much moisture is going to be left for us, because every shower, every thunderstorm, even the snow up here in the Dakotas was taking a bite out of this atmosphere here. Now how much can be wrapped around in here? Now you can see we still had some snow here across the Wind River Basin. Now there was snow across the eastern portion of the state. We just don't have good radar coverage out here, so we can't see it. Another way we look at this is the skew T. Now when you see us launch the weather balloons, this is where this comes from. It measures 3 things: temperature, humidity, as well as the wind. Now these 2 lines are temperature and humidity. One on the right is temperature, one on the left is humidity. Now you can see how these are pretty closely together all the way up to about what meteorologists call the tropopause. It means we have a very saturated atmosphere, a lot of moisture to work with, so decent for snow there. The other thing I want you to notice is over here on the wind bar. So you can see northeast, that's a good direction for us. In the low levels you can see north wind. This is good for upslope snow. You see about 35 knots. It's pretty good upslope there, so areas that are favored by that, like Lander, Riverton, Thermopolis, and also Casper, did pretty well out of this. When we take a look at the snowfall amounts, you can see, yeah. Now the highest here is where the edge of that deeper wraparound moisture came into the east of the Bighorns. 12 inches around Buffalo, about 10 around Casper, more as you headed up Casper Mountain. The highest amount we saw was 24 inches. That was the Edgerton Midwest area. Also Thermopolis about 6 inches, 9 here to the south of Meeteetse, anywhere from 8 to 12 across the Wind River Basin. Western mountains as you head out to the west, about 10. That was on top of Jackson Hole. 4 inches at Afton, about 5 around Rock Springs, 7 at Farson, and about 4, generally about 4 around the Cody area. But there was another component to this. Now, this is the surface chart again. I know it's a little bit blurry, but notice here, you see these are pressure lines here, what meteorologists call isobars. And those are pretty closely packed together. When you see that, that's what's called a pressure gradient. Usually when you get that, you get some pretty good wind across the area. You see they're really tightly packed over in here. There were blizzard conditions out in here. We actually had some blizzard conditions over here across eastern parts of our area, especially Johnson County. They saw strong winds for several days with this. And the result, the main impact, this was what the roads looked like, I think, on the 13th of December. You can see just about every road across Wyoming in the orange. That's very rough travel conditions. I-80 was closed for a while at that time, as well as 287, and I believe up north of Buffalo, this was closed for a while as well, but very difficult travel conditions across much of the area. I remember trying to get to work that day. It was not fun at all. We'll have number 2 tomorrow.